So I'm going to talk a little bit about really how Aerospike can help you reduce some carbon emissions and stuff, primarily from an IT perspective, right? Raghu talked about really an overall context. But before I get started, it seems like everyone is focused on sustainability, right? I was told that you cannot come to India without talking about cricket or Bollywood. I don't know if that's true or not. I didn't get an example on Bollywood, but at least have an example on cricket here where the ICC, even for the World Cup that is upcoming, is really looking at how they can do it in a sustainable fashion. And then you also see that the IPL also wanted to make sure that that's part of their equation going forward. So it seems like everybody is focused on sustainability, or at least finding a way to take some baby steps towards that goal. When you look at really the carbon impact of IT and AI, it's actually pretty massive. So I have some numbers here to just show you that if you look at some of the survey data out there, the global electricity consumption by just computers that we use every day is forecast to go about 20%, right? 8 to 21% by 2030. That's just 7 years from today. It's already north of 6% of all kind of electric consumption is done by computers. It's pretty significant when you look at it 7 years from today. We talk a lot about AI, and there's a lot of press, there's a lot of material that's being written on this around what it takes to train an AI model. And you can see it here. It's really an AI model consumes so much carbon dioxide, it's actually emitting about 5x an American car's lifetime emission, right? You can say maybe in India we drive smaller cars, so it's maybe 3x. But still, 3x of emissions, if that were indeed the right number, of lifetime emissions, okay, from a car, is what it takes to train a single AI model. And then this is actually a very startling fact, right? I hadn't realized this, but this comes from MIT, that cloud computing's carbon footprint is now exceeding that of the airline industry, right? So this is pretty significant in terms of the impact that IT and in the future AI is having essentially on emissions and carbon footprint. And why is that happening? There's actually a paradox here. If you look at a society or a country like India, it's fast digitizing, right? The success of UPI and financial systems, digital payment systems, India is lauded for the right reasons for doing that. I traveled here, I guess 4 or 6 months back, I don't remember, and I think I felt like I was the only guy moving around with a credit card. I still haven't figured out how to make phone pay. Hopefully the phone pay guys can help me work that, because it doesn't work with my US accounts. So, but that is really amazing in terms of what India has been able to do from a digital transformation in the financial sector, for sure. Along with that, that digital transformation is actually creating a paradox in terms of how do you do that, but do that actually with reducing resource consumption. Because that demand on digitization, which started maybe in India in financial, is going to impact every aspect of society. Healthcare probably will be the next. And who knows, what after that. And it's not just India, right? It's all kind of fast-growing economies and countries out there. And a lot of it is really, digitization is built on usage of data. We talked about AI. We talked about multi-cloud, edge computing, so on and so forth. All of that actually creates significant pressure on carbon emissions and resource consumption. So the question is there a better way to do this? And we believe there is, and efficiency is the answer. And the way we think about it is, obviously, we are a provider of a database platform. And when we looked at it, we feel the choice of your database matters from a TCO perspective, as Avik talked about, but also from an emissions perspective. Here are a couple of kind of charts here. And you can get this paper on the link that is published out there at the bottom of the slide. But if you look at just the annual emissions per terabyte of data on Cassandra versus Aerospike, right? Aerospike is roughly 1/5 of Cassandra. Everybody knows Cassandra here, right? It's open source, it's pretty prevalent out there. So everybody pretty much has heard of it. But look at the significant difference in terms of the annual emissions per terabyte of data vis-a-vis Aerospike and Cassandra. And you take that and then look at basically TCO for 1 petabyte of data as a total cost of ownership annualized. That is again significantly lower. So again, it's about 20% of where Cassandra comes out. So the choice of database definitely will help both from a TCO perspective and then from actually reducing carbon footprint or sustainability goals. If your company has those goals or the country has goals, these small steps make a huge difference. So how do we do this? And I'm going to talk a little bit about why database choice matters and how architecture that we chose made all the difference in terms of actually helping with this goal. So Aerospike's unique architecture actually helps you do the same amount of work with much fewer servers. So here are 3 examples, all 3 global customers, Wayfair, PayPal, and Criteo. You may have heard of Wayfair and PayPal, but you may not have heard of Criteo. But what this shows you here is really, when you look at Wayfair, they were able to go from 60 Cassandra nodes to 7 Aerospike nodes. When you look at PayPal, they were on Terracotta, and I'll talk a little bit more about what PayPal actually accomplished and what the use case was. 360 nodes to 20 nodes on Aerospike, not compromising performance or SLAs or availability and so on and so forth. And then Criteo, which is a large ad tech firm based out of Europe, was on Couch, 5,000 node Couch cluster, shrunk it to 600 nodes of Aerospike. And I'll talk a little bit more about that. But these are indisputable numbers in terms of how we are able to really reduce the server count pretty significantly, sometimes 80% to 90% reduction in server count. You take that and you think about what I presented before in terms of how much carbon emissions actually are coming out just from usage of computers. It is bound to have a pretty significant impact if you reduce the number of nodes or number of servers that a database needs, right, for your workload. Let's talk a little bit about Criteo. So Criteo, pretty large business, 4 billion ads daily, okay? People here in the ad tech business, mobile advertising, I don't know if there are folks from InMobi or any of the Flipkarts here, Myntra is here. I'm sure, you know, there's a lot of advertising supported businesses out there. But Criteo, big DSP, big ad tech firm, 4 billion ads daily. We talked about the raw numbers, server reduction of 88%. They closed down 2 data centers. They were able to close down 2 data centers when they moved from Couch over to Aerospike, while supporting 8x data growth. Okay, it's not just saying, let me kind of reduce it and consolidate it on a few set of nodes, but the data needs are constantly growing. So it's not just about being able to do this significant efficiency for now, but also future-proof your growth with Aerospike. Okay, and you can see their peak TPS is about 200 million. Pretty significant, actually, success story. You can actually read, if you kind of Google Aerospike, Criteo, TechCrunch, there's a TechCrunch article that talks about in detail how they accomplished it. And I think they also published a Medium article, so you can read through it if you're interested in terms of the architectural design and so on and so forth. So that's Criteo. PayPal. Anybody heard of PayPal? Okay, I think few people have heard of PayPal. Others are saying I use PhonePe, others are saying no, I use Paytm. But nevertheless, PayPal. So what they did was they had an issue with fraud in that they were basically missing out on SLAs on few of their transactions. Okay, so about 2% of the transactions, they couldn't meet the SLA. So if you're paying somebody for a transaction, the customer is not going to wait around for 15, 20, 30 milliseconds for the vendor to say yes, good, or bad. And that was the issue that PayPal had. There were timeouts happening on their fraud engine, and they were essentially having to let transactions go through because it couldn't respond in the SLA that they had. As a result, they had to actually take risk on their books. So when you let a transaction go through without really being assessing whether it's a fraudulent or a good transaction, you essentially say, I'm going to let it go through, and I'm going to underwrite that as risk on my P&L, right? So that's where it started. At the same time, the fraud team and the business said, if we can get more data to work, right? Raghu talked about variety, volume, veracity, and velocity of data. The same thing holds good here. What's fraud? Fraud is really trying to bring in data from a variety of different sources and trying to really assess whether there's a good transaction or a bad transaction. And in PayPal's case, they wanted to put a lot more data to work so that they can be actually more confident on the fraud score. So already there was a problem that they were missing SLAs with the current data set, and they had aspirations to actually grow their data significantly. So with Aerospike, they were able to grow their data set by 10x. So you can see in the bottom, it says from 10 terabytes to 100 terabytes, now feeding the fraud engine. And they were able to actually reduce the SLA misses significantly, right? So where they had like millions of dollars of exposure, they were able to bring it down to like hundreds of thousands of dollars. So pretty significant success story. This is actually a graph implementation. Their fraud solution is actually a graph implementation on top of Aerospike to power their fraud analysis of fraud detection engine. Again, we talked about the server reduction that PayPal was able to accomplish. The second aspect of this is it's not just reducing the number of servers. We actually also give you the ability to run on more efficiently on ARM-based processors. So we already ported last year Aerospike to Graviton, and you can see the numbers here, 63% price performance improvement, reduced cost. For the last point, almost 50% carbon footprint reduction. So not only can you slash the number of servers that you need with Aerospike compared to kind of other kind of solutions in the market, but by running on AWS Graviton, and we'll be looking at porting Aerospike onto basically other cloud vendors' ARM processors also pretty shortly. But this is what we did last year, working with AWS. And this benchmark is also available with this QR code. You can see and read through that paper. So I'm going to just quickly touch on how we are able to accomplish this. Srini, when he comes here, will talk a little bit more about the architecture. He can talk about it better than I can because he actually designed it, right? But the secret to the story is really hybrid memory architecture. And the folks in the room who use Aerospike know about this. It simply means we store indexes in memory and data on SSDs. But we do that while giving you near memory performance in terms of being able to access that data. As a result, you can attach a lot more data to every node in a distributed database cluster. As a result, we need fewer nodes, right? Talking about how we can actually accomplish the reduced server count. There's a bunch of other stuff, what you would expect in a classic database. This is a NoSQL database, of course, but we have advanced cluster management, geo-distributed transactions, parallel processing, massively parallel processing to actually help deliver on the predictable performance and the low latency that Avik talked about. We have algorithms that basically make sure that if a node goes down, the application doesn't get affected and so on and so forth. That's how we can deliver this impressive availability that Avik mentioned before, okay? Now, remember the 4 tenets that Avik talked about: predictable performance, low latency, high availability, and low TCO. All of those 4 tenets are available no matter which data model you actually choose. So we started as a key value data store. Last year, we added support for documents. We were always a document data store, but we had our own compounded data types, as we called it. But now, last year, we supported JSON. So you can actually store and access JSON objects in the database, in the Aerospike database. And then this year, in July, we actually released the first version of Graph, okay? And these have kind of use cases, some of the use cases that Graph obviously fuels out there. We talked about PayPal, which actually built their own Graph solution before we released Graph. And this is based on Apache Tinkerpop, our Graph solution, and it uses the Gremlin query language to actually retrieve objects and interact with the database itself. The way we actually build this graph, it actually brings the Aerospike benefits to a graph solution. So it's meant for scalable graph. So we can support a graph with billions of vertices, each with thousands of edges, and yet deliver 100K plus QPS, right, queries per second. So really massive graphs do amazingly well on Aerospike. And then I heard some people talk about really vectors. If you're interested in vectors, we are working on vectors, and we'll be releasing that shortly here. Obviously, a lot of excitement on vectors with generative AI and other use cases around similarity searches, maybe recommendation engines, and so on and so forth. So with that, I want to kind of quickly share a video. So if you can play the video, please.
On sites like Hugging Face. These models take large files like images or large amounts of text and generate vector embeddings from them. This allows you to create similarity searches and generative techniques. And we're going to be using the CLIP model from OpenAI to perform image recognition and similarity search. In addition to these models, the other reason that vectors are popular is a new algorithm called HNSW, or Hierarchical Navigable Small World. This algorithm allows you to reduce the vector space you have to traverse to perform a proximity search. And we've implemented this on top of Aerospike and used it to index over 1 million images. And this demo does not use any GPU hardware. We're running this on normal CPUs. We'll take a look at performing image similarity search here. I'll search for an image of pyramids, and you'll see even without that GPU hardware, we're able to achieve excellent performance. Our overall time was under 500, or just over 500 milliseconds, and our query time was under 20 milliseconds. I'm going to repeat that with an image already on the server here, and you'll see our results are nearly real time, with the total time being less than 100 milliseconds and the query time being less than 20 milliseconds.
So that was a pretty quick video just to show this is in the labs. This is a real demo. I didn't want to run a real demo because I know Murphy would catch up with me. So I asked Adam, our product manager, to actually record that video. If you're interested in vectors, talk to the Aerospike team. It's not ready for release. As I said, it's in the labs. We would love feedback from folks who have interest in vectors and AI initiatives, and how they are thinking about leveraging vector data types within their AI pipelines and so on and so forth. Are you using large language models, your own kind of data, and chaining all that together? Would love to actually talk with you to understand what your needs are specifically. Just to touch on where we think the future of AI is. Right now, as you guys know, people who are using AI models and are leveraging AI within your organizations, a lot of the training happens offline, right? You get a bunch of data stream that comes in, you push it to a model which is offline learning, and you may actually contextualize that with your own data, your own proprietary data. And then, usually on a nightly basis or twice a week or whatever, the features that are kind of generated by the model are pushed back for really usage for real-time decisioning. So in this picture, where we believe the future needs to go with AI is you can use basically third-party models, your own data, so that you can have more context and richer data set, if you will. Feed that into a platform like Aerospike for persistent, but more importantly, you actually want to get to more continuous learning. So it's not offline learning, so that you can actually make real-time decisions, right? Not semi-real time or near real time. Because think about a recommendation engine, right? I'm just using a simple use case. And if Frank here is shopping, you would love to know what Frank has in his basket at that point in time and give him the relevant recommendations based on a lot of the behavior, not analysis of Frank's behavior from a week back. Okay, and to do that, you need a real-time data platform to be able to actually respond to your needs as quickly as possible. And I think we believe we can do that, moving more to a continuous learning model. One kind of announcement I also wanted to make here is we started an initiative around database as a service last year. And today, we are actually announcing that it's available in beta for the free trial. So if you're interested in trying out Aerospike Cloud, as we are calling it. It is a purely frictionless database as a service. The free trial is available for you to play with. So again, that QR code or control.aerospike.cloud, you can go register and start playing with it. It's a free trial that's available to everybody. And pretty shortly, we'll be putting it out for general availability, okay? So when it's released, it will have a free trial and it'll have a bunch of different, think about it as t-shirt size instances, small, medium, large, extra large, available for you to buy and build your applications on top of. Okay, so if you're interested in database as a service from Aerospike, go to this URL or this QR code and you can register for the free trial available now. So in summary, what I wanted to leave you guys with is it is possible for us to build a sustainable future. It's not a lofty goal. As Raghu said, small steps will help us get there. You saw some of the impact that we are having using computers and IT and AI. Can we do it a little more efficiently is the question in front of us. And as far as data platforms are concerned, we believe database choices do make a difference. It matters. From our perspective, we can actually help you on your initiatives by helping you drive sustainable, reduce carbon footprint, use more efficient servers and processors like Graviton, and in the future, other ARM-based processors, which we will port the database to. And we want to do that not just for today, but we'll continue to innovate so that we also support a sustainable future from an IT perspective. Okay? So with that, have a great rest of the day, and thank you very much. Any questions? Oh, questions? Okay. I wasn't told, but I'll take questions. Yes, please.
You spoke a lot about data, but don't you think that legacy and historical data will not play a role for final analysis or predictive analytics as such? Because in a dynamic environment, the situation keeps changing very fast.
Yeah, so I mean, what I see people do out there is, there's the concept of TTL, or time to live, as far as data is concerned, right? So usually value of data decreases the longer it is live, right? So the trick here is to really understand your use case and what you're trying to do and what's really relevant for that particular use case, or what you're trying to accomplish in terms of the decisioning. So maybe all the data will not be relevant for that particular use case. So you want a combination of data that has been generated maybe a month back, maybe in some cases it's just a week back, and combine it with stuff that is happening more on a dynamic or real-time basis. When we talk about even AI, we're talking about really using off-the-shelf models, whether they are LLMs, large language models, or SLMs, but combining it with really your own data. Because most companies will have a data set which is proprietary and will have a lot more context, richer context than what's just available in an off-the-shelf model, right? So it's always going to be a combination of whether it's kind of third-party data with your own data, and maybe, as you said, right, legacy data plus more dynamic or real-time data. So I'm not saying that legacy data is dead, but you may not need to keep data around for 6 months, 8 months, 9 months, unless there is regulatory reasons that you want to actually have to store data, right? For decisioning purposes, you have to make the choices based on what your use case is specifically. Okay. Other questions?
Thank you.
Yes, please.
Hi. This data storage is only in one place, or you have got replication of the data also?
We support replication.
2 sets, 3 sets kind of.
Yeah, we can do RF2, RF3, whatever, right? So we can, yeah, absolutely. Yeah. Other questions? Last question, Sharon says.
So whatever the number of server count you told, right? That is the caching server or the actual database?
Actual database.
Actual database.
Yes. Yeah.
And it has some specific hardware need, or?
I mean, it's kind of it is basically hardware that's available in the cloud or your own hardware. We are not specific on what we care about is really memory to kind of disk ratio, which matters a lot for us. So as long as you're within those parameters, it'll work for you. Okay. That's it. I guess I'm not allowed to take any more questions. So thank you.